Indices is expression of values in power or exponential. The first law, multiplication. When we have values of the same base, their powers are added. A good example, we have 5 raised to power 3 multiplied by 5 raised to power 4. The bases are the same, and so we can have 5 raised to power 3 plus 4. That gives us 5 raised to power 7. The second law is the division law, whereby having the same base, we subtract the index from each other. So looking at the example, we can see that the base is 20, so we can subtract 5 from 7 and the value will give us 20 raised to the power of 2. The next one is negative index, which is reciprocal. A raised to power minus 1 means 1 over a. A raised to power minus x means 1 over a raised to power x. And so let's look at an example. 2 raised to power minus 3 will be 1 over 2 raised to power 3, which will give us 1 raised to power 8. So when we have fractional index, they are expressed in terms of roots. And so when it is raised to power half, is the root of the value. When it is raised to power 1 over 3, we are going to have that as the cube root of the value. Example, 5 raised to power 1 over 3 will give us the cube root of 5. Generally, we can say a value raised to the index of 1 over x means that we find the x root of that value. So what happens when we have a value that raised to a fraction? So the denominator becomes the root, like white root of a, all raised to the power of x. An example, we have 27 raised to the power of 2 over 3. We have 27 expressed as the cube root of 27, all raised to the power of 2. Cube root of 27 is 3 raised to the power of 2. The answer gives us 9. So we move on to index of an index. It means an index that already has an exponential. If it has an external exponential, we multiply the exponentials together. And so 5 raised to the power 2 all raised to the power 3 will give 5 raised to the power 2 times 3, which will be 5 raised to the power of 6. Then here we have the zero index. Any value whatsoever raised to the power of 0 will definitely give 1. So irrespective of how small or how big the value is, once it is raised to the power of 0, we get 1. Examples, we can have values like 200 raised to the power of 0, it will give us 1. We can have values like 5 raised to the power of 0, 1. 99 to the power of 0 is still 1. Affirming that any value raised to the power of 0 is 1. So let's look at some examples. Here we have this 81 over 16 all raised to the power of minus quarter multiplied by 2 raised to the power minus 1. What do? We express 81 and 16 in their lowest form. And that will give us 81 is expressed in terms of 3 as 3 raised to the power 4. Same way 16 will give us 2 raised to the power 4, all values raised to the power minus quarter. Multiplied by 2 raised to the power minus 1 will give us 1 over 2 from our previous law. And so we see that 3 raised to the power 2 and 2, we have an index of 4. Then all raised to the power of minus 1 over 4 multiplied by half. Using index of an index, we get 3 raised to the power 2. The index will be 4 multiplied by minus 1 over 4. And then we multiply our answer by half. So 4 taking out 4, we are left with 3 over 2 raised to the power minus 1, to which 3 over 2, going by the law of negative index, will be 1 over 3 over 2, and that will give us the reciprocal, which will be 2 over 3. Multiplying that by half, we get 1 over 3. So if we move to the next example, we can see that we have majority here as index of an index. The first value there, a raised to the power 3, all raised to the power 0. Then a raised to the power half raised to the power 4. Anything raised to the power 0 is 1. So a raised to the power half we multiply 4 outside. And so we are left with a raised to the power 2. That is the final answer there. Then we look at this, looking a little complicated, but it's quite easy. Let's dive in. So diving in, we have 5 x raised to power 5 y raised to power 2 multiplied by 3 x y raised to power 3 all squared over 15 x raised to power square raised y. Here we sort the index of an index that is found in 3 into x y cubed squared. So multiplying the indexes with the square outside, we see that x raised to power 2, 3 multiply 2 to make y raised to power 6. And in doing so, we have 5 times 3, 15. Then following the indices of multiplication, x raised to power 5 times x raised to power 2, we add their indexes up. The same with y, and so that will give us 15 x raised to power 7, y raised to power 8 over 15x squared y. 15 takes out 15, leaving us with x raised to power 7, y raised to power 8 over x squared y. So using division law, we subtract the index of the y of the x squared from x7 and that of y from 8. So in the end, we are left with that. And here comes another example. If 4x raised to power 3 equals to 16x plus 1, we express 16 as a base of 4, which should be 4 squared. And so by expanding that, we get 4x raised to power 3x equals to 4 raised to power 2x plus 2. And because their bases are equal, we can equate their index and then collect like terms, and the answer gives us x equals to 2. In this particular question, in question 5, we can express all in the base of 5. 25 we end up being raised to the power of we end up as 5 raised to power 2, and so multiplying the index, it is raised to 2n minus 2 minus 3, and then that will give us 5 raised to power 0 will give us 1. So here we have 5n plus 3 over 5 raised to power 2 into 2n minus 6 being expanded, you have that. So this is 1. Cross multiply on both ends. You can have 5 raised to power n plus 3 equals 5 raised to power 4n minus 6. They have equal base, so therefore we compare their power. N plus 3 equals to 4n minus 6. Collect like terms. We'll see that we have n minus 4n equals to this. Divide both sides by minus 3, and n equals to positive 3. In this next example, we can express every value in that as a base of 2. 16 as a base of 2, 4 as a base of 2, 8 as a base of 2. So 16 as a base of 2 will give us 2 raised to power 4, while we have 4 to the power, to the base of 2 will be 2 raised to power 2, and then 8 to the power of, to the base of 2 will give us 2 raised to power 3. So using the multiplication law, we add up the indexes of each of them because we are multiplying, and so we add an index. And that being true, we can always compare their base because they have equal bases, and then having compared their base, we can equate their index to each other. And all we have to do, having equate their index to each other, is that we collect like terms. And so as a result, collecting like terms, we can divide both sides. We can see 5 plus x equals to minus x plus 3. Collect like terms, and then 2x equals to minus 2. Divide both sides by 2, and x equals to minus 1. In the next example, we have something that is given to us that looks more like a simultaneous equation. We're given two equations here, and we have to solve for the values of x and y. So expressing each of them as a base of 3, we can see 27 will be raised to 3, while 243 will be 3 raised to the power of 5. And of course, they share the same base, so we can always equate their power. x minus y will be equals to 3, x plus y will be equals to 5. And so when we solve this simultaneously, I will be using elimination and substitution method. So using elimination method as a method of simultaneous equation, we are going to have x minus y equals 3x plus y equals 5. And so if I add up both sides, I will get 2x minus y and plus y will cancel out. And 3 plus 5 is 8. Dividing both sides, x equals to 4. So I can substitute for 4 in any of the two equations given. So I'm choosing x plus y equals to 5. I replace x with 4 and then I collect like terms. That means y equals to 5 minus 4, y equals to 1. Very easy. Next, I'm given this. If x raised to power y equals to 125, then we have to solve whatever is next using that solution. So here we have x raised to power y equals to 125. All I have to do is express 125 in its simplest form of index. And so we can see 125 is 5 raised to power 3. So comparing that, we discover 5x equals to 5 and y will be equals to 3. And so using that, I will have 5 minus 1 raised to power 3 plus 1. And so this will give me 4 raised to power 4, which will give me 256. Thank you for watching. Kindly try this and drop your answer in the comment section. See you in the next one. Watch out. Logarithm. Bye.